Welcome friends to our third session, and in this session we are continuing with our topic oxidation and reduction reactions. Those who have not yet watched our previous session about oxidation numbers, we can first check on it because this is a continuation. In this session we are looking at how can we use oxidation numbers to know whether a substance has been oxidized or reduced. How can we use oxidation numbers to identify a reducing agent and oxidizing agent? How can we use that to determine a half equation for a given reaction? So today we are going to consider this reaction, the reaction between magnesium and oxygen to form magnesium oxide. So when you consider this reaction and using our knowledge that we got from oxidation numbers, we can first assign each of these species oxidation numbers. We find out which one has been oxidized, which one has been reduced. Don't forget, when we say oxidation, it is removal of electrons, while reduction is addition of electrons. So when we look at this equation, magnesium reacting with oxygen to produce magnesium oxide, we said that for free elements or uncombined elements, like now here we have magnesium, its oxidation number is 0, which is the same case with oxygen. It is an combined element, therefore its oxidation number is 0. Now, look at the product it forms, that is magnesium oxide. In this is a bond that magnesium, when magnesium reacted with oxygen, there is a bond it is forming with oxygen. And at this point, we see that magnesium forms an ion of 2 plus and an ion of 2 minus. And we say that oxidation numbers of simple ions, their charges is equal to their oxidation numbers. So here we can say oxidation number of magnesium in this compound is positive 2. Oxidation number of oxygen in this compound is negative 2. So we can see in this equation, the oxidation number of magnesium from here, the reactant side, is changing from 0 and then it is moving to negative to positive 2. It is moving from this 0 and then it is coming to positive 2. So it is increasing. While for oxygen, it is coming from 0 and is reducing to negative 2. So what do we say? So in that case, we can say that magnesium has been oxidized. It has been oxidized from 0 to positive 2. While oxygen has been reduced from 0 to negative 2. Now, when oxidation number increases and this substance has been oxidized, therefore it has undergone what we call oxidation. Why? Because we can see it is moving from 0 to positive 2, and this positive 2, it means that there is removal of electrons. While for this one, there is addition of electrons, so it underwent reduction reaction. That is oxygen, while magnesium has undergone oxidation reaction. Now the question is, among these two, which one is reducing agent and which one is an oxidizing agent? So the one which has been oxidized, one which is oxidized, is the one that we call reducing agent. The one which has been reduced is the one we call an oxidizing agent. Why? Because when you see oxygen is the one causing magnesium to be oxidized, because it is oxygen that is receiving the what? Electrons which are coming from magnesium. Therefore, we call the oxygen an oxidizing agent. While for magnesium, it is the one causing oxygen also to be reduced because it is giving electrons to oxygen. Therefore, we call that one a reducing agent. And as we said, mostly metals are reducing agents. Why? Because metals are electron donors, while non-metals are good oxidizing agents. Why? Because they are electron acceptors. So that's how we can summarize an oxidizing agent and a reducing agent. Now, when you're writing equation, half equation, we want to find which one is half equation for oxidation and half equation for reduction. We use oxidation number. This one has moved from 0 to positive 2. This is from 0 to negative 2. So when you come here, you can have two half equations. We have magnesium being oxidized to magnesium ion, and then oxygen being reduced to oxygen ion. So we are balancing the equation, the electrons here, because here we have two atoms of oxygen. We also need to add a 2 here so that it balances. But when you balance and you put a 2, it will also affect the what? The electrons. So here we have 2 times negative 2, which gives negative 4. So for us to balance, we have to add 4 electrons here, and then it is balanced. And then we say this is reduction reaction, and then magnesium is undergoing oxidation reaction. In simple way, you can view oxidation reaction is, for oxidation reaction, electrons are on their right hand side, while for reduction, electrons are on the other, on this side. So this is for reduction, and then this is for oxidation. So when you look at this example number 2, we have zinc. Reacting with hydrochloric acid to produce hydrogen and zinc chloride. So feel free to pause and then you try out this number. Find out which one has been oxidized, which one has been reduced, and which is a reducing agent and which one is an oxidizing agent. Please, you can pause and then you try out, you see whether you have passed it or not. So when you look at this, when we look at this equation, having zinc, and we say that zinc is a free element, and we said free elements, their oxidation numbers are 0, and even hydrogen, we see it is also a free element, which means its oxidation number is also 0. So we can say for hydrogen, you have oxidation number 0, zinc, oxidation number of 0. Then we go to hydrochloric acid. It has hydrogen and chlorine, which are formed bond together. So we said for chlorine, which are halogens, for them they have oxidation number of -1, and while hydrogen has oxidation number of +1. Then when you come in this product, which is zinc chloride, we see zinc having oxidation number of +2, and yet chlorine has oxidation number of -1. So you can see for chlorine, its oxidation number is not changing. It is not changing. It is -1 here, and it is also -1 here. While for zinc, we can see it is increasing from 0 to +2. Hydrogen, it is changing from +1, reducing to 0. So in this case, we say that zinc has been oxidized from 0 to +2, while hydrogen has been reduced from +1 to 0. So, and zinc has undergone oxidation and hydrogen is undergoing reduction. Why are we saying it has been oxidized? There is increase in oxidation number from 0 to positive 2. Why are we saying it is reduced? Is moving from positive 1 to 0. So we say that is reduction reaction, and this is oxidation reaction. And we say the one which is oxidized is called a reducing agent because it is the one, it is electron donor. It is the one which has donated, it is the one which has caused the other to be reduced. So it says zinc is a reducing agent, while the hydrogen in the hydrochloric acid is an oxidizing agent. So in the half equation, we shall have zinc forming zinc ion and then hydrogen forming hydrogen gas. So which means we shall have the half equation here where we have zinc forming zinc ion plus 2 electrons. The removal of electrons, and we say that is oxidation reaction. While for hydrogen ions receive 2 electrons to form hydrogen gas, and we're saying this is reduction reaction. So that one will get your score very well. So I believe that one becomes very clear for us by understanding how we can use oxidation numbers to determine which one has been oxidized, which one has been reduced, identifying reducing agent and oxidizing agent. It is yours now to try out example 3. Pause and you try it out wherever you are in your book, and then after you prove your answer whether it is correct, and also knowing whether you are getting this concept very well. So we have methane reacting with oxygen to produce carbon dioxide gas and water. Still we want to find out which one is an oxidizing agent, which one is a reducing agent, which one has been oxidized and which one has been reduced. So here we can first look for a combined or free element, and we have oxygen. So oxygen will have an oxidation number of 0. Then we have for hydrogen, we said its oxidation number is positive 1. Now for carbon, when we're looking at oxidation numbers, we said that for carbon, its oxidation numbers changes depending on what? Depending on the compound. So we shall calculate for that. Oxygen, we say it is 0 because it is a combined element. Then we have still carbon in a compound. We said its oxidation numbers change. So we shall be able to calculate. For oxygen, we already saw that in the rules that of assigning, it has negative 2. Then for hydrogen, it has positive 1. And oxygen has negative 2. So we can calculate for carbon in this compound. We calculate oxidation number of carbon in this compound. And then we shall be able to know which one has undergone oxidation, which one has undergone reduction, and that manner. So calculating oxidation numbers of carbon. Calculating oxidation number of carbon in methane and carbon in carbon dioxide. So for methane, you can see saying that summation of oxidation numbers in a neutral compound is equal to 0, or in a neutral molecule is equal to 0. So the oxidation number of carbon plus oxidation number of hydrogen, but we have 4 hydrogen atoms. So 4 times the oxidation number of hydrogen is equal to 0. So carbon, oxidation number of carbon plus 4 times oxidation number of hydrogen, which is 1, is equal to 0. So we get carbon plus 4 equal to 0, and then oxidational number of carbon in methane. Oxidation number of carbon in methane is the one we are getting as negative 4. And when we come here, we are seeing carbon dioxide. What is oxidational number of carbon in carbon dioxide? The same. This is still a neutral molecule. It doesn't have any charge. Therefore, we equate the sum of oxidation numbers to 0. So oxidation number of carbon plus 2. 2 is coming from the 2 atoms of oxygen. So 2 times oxidation number of oxygen, which is -2, equals to 0. So it will be carbon, oxidation number of carbon plus, to be -4, 2 times -2, which is -4, equals to 0. So this will be carbon equating it to +4. So oxidation number of carbon in carbon dioxide is +4. So from there, we can now assign them all the oxidation numbers. So we have seen that oxidation number of carbon here is -4. Oxidation number of carbon here is +4. So what do we see? We can see that for hydrogen, its oxidation number is not changing. I think +1. In here, it remains as +1. What about carbon? It is moving from -4 to +4. This is increase. What about oxygen? It is coming from 0 to negative. I think there is reduction. So on oxygen there is reduction. On carbon there is oxidation. I believe we see it very well. So which means you can say on the carbon side it has been oxidized, and on oxygen side it has been reduced. Therefore it has gone through reduction reaction here, and then here on this side it has gone through oxidation reaction. It has gone through oxidation reaction. So in that case we can say methane is a reducing agent in that case, while oxygen is an oxidizing agent. Now, we want also to use the same knowledge of oxidation numbers to identify whether the reaction is a redox or not. Did you know that some equations, some reactions may not be redox reaction? Because we said in redox reaction, oxidation and reduction reactions take place simultaneously. So when you find that there is no oxidation taking place and reduction taking place, we say that is not a redox reaction. But there is a quick way we can find that. Let's go through this. We're saying that for redox reaction, there must be a change in the oxidation numbers. There must be change in the oxidation numbers. If there is no change in oxidation numbers, then we say that is not a redox reaction. So let's look at this example. So example 1, we're having aluminium reacting with copper to chloride to produce aluminium chloride and copper. Now the question is this one a redox reaction or not? How do we know that? Is by assigning each of these substances their respective oxidation numbers. If there is any change in the oxidation numbers, then we say it is a redox reaction. Let's have a quick look at this. We said that for free elements like aluminium, its oxidation number is 0. Another free element we have copper, its oxidation number remains as 0. And then for copper in this compound, its oxidation number is 2, +2. Chlorine, it is -1. I believe now we know where all these are coming from. For those who have gone through our session in oxidation numbers, please, if you haven't gone through that session of oxidation numbers, let's run there, because now we are going through this knowing that we have all gone through the oxidation numbers in the previous session. Then in this compound you have aluminium with +3 and chlorine with -1. Okay, so can see for aluminium it is changing from 0 to positive 3, while for copper it is moving from positive 2 to 0. Are you seeing this reducing? This is reducing. While for aluminium it is increasing. So we say this is a redox reaction. Are we there? We say it is a redox reaction. So let's try out this. Please pause and you try out these questions. Look at this. Magnesium oxide and water react to form magnesium hydroxide. Is this a redox reaction or not? Number 2. Zinc reacting with chlorine to form zinc chloride. Is it a redox reaction or not? Let's look at solution, but for you can pause and first try them out. Then at the end of it all, you tell me whether you have passed it or not, and how did you find it. That's what I want us to know. But what you said, if there is no change in oxidation number, then that is not a redox reaction. Let's quick look at this. Number 1, magnesium oxide. Magnesium oxide. Magnesium has oxidation number of positive 2. Oxygen negative 2, hydrogen positive 1, and oxygen negative 2. By now, I believe everyone knows where the positive 1 is coming from, negative 1 is coming from, because we looked at oxidation numbers. Now, in this compound, we have magnesium having oxidation number of positive 2, oxygen having oxidation number of negative 2 and positive 1. I believe we know where this one comes from, because we said that for hydroxide, oxygen has a negative 2 and hydrogen has positive 1. So the net charge here, it becomes negative 1. That's why for hydroxide it is always you have O. OH, you have OH, then minus. Where the minus comes from is the negative 2 on oxygen and positive 1 on hydrogen. You add the negative 2 and positive 1, you get a net charge of negative. Can we have a quick look at magnesium? What is happening with magnesium? Positive 2, positive 2. Is there any change? No. High oxygen, negative 2. Even here it is negative 2. Look at here, negative 2. No change. Look at hydrogen, positive 1. Positive 1. No change. So you can find and see very well that in this case there is no change in the oxidation numbers of these substances. Therefore, we say this is not a redox reaction. So this is a very good answer. It is not a redox reaction. Another one, we're saying that zinc reacting with, we have zinc reacting with chlorine to form zinc chloride. We say that for zinc it is a free element, therefore its oxidation number is 0, and then chlorine is a free and combined element, its oxidation number also 0. Now in this product we have zinc chloride. Chlorine, we say that the oxidation numbers is a halogens, the group 7 elements. We said they have a negative 1 oxidation number, and zinc here it has positive 2 oxidation number. And whenever it confuses you to know oxidation number of zinc, like here, you can always calculate for it. Why? Because you already know for this halogen. So you let it be unknown plus this negative for chlorine, you equate it to 0. And you can calculate. When you calculate, you find it is positive 2. The reason why I'm putting it here is because I know we have already gone through our first session. So we can see, tell me, has it increased? Is the oxidation number of these substances increasing or decreasing? Is there any change? Let's look at zinc. Zinc, it has been 2 and now it is becoming what? Positive 2. There is a change. Chlorine, it has been 0. It is now -1. There is a change. One is undergoing oxidation, another one is undergoing reduction. So therefore, we say this is a redox reaction. Quick notice that you can use also to know that this is a redox or not. Any reaction that is taking place and doesn't have any free or uncombined element, most unlikely that reaction is not a redox reaction. An example is here. But in all those where there is some uncombined or free element, you find this always a redox reaction. Let's look at some of the decomposition reactions. You have a substance decomposing to form substances. So we have this. Please, you can try. Which of the above reactions is a redox reaction and why? So we have mercury oxide decomposing to form mercury and oxygen, calcium carbonate decomposing to form calcium oxide and carbon dioxide gas. Which of the above reactions is a redox reaction and why? Let's go through very fast. But as I said, when you look at this, which one has a free and uncombined element, we see that A could be probably one of the required, but we haven't tested. We're going to test. But I think this one doesn't have any uncombined. You see, combined. At the end of it all, you find that there is no change in oxidation number. Therefore, you find it is not a redox reaction. Let's go through proof and we see. So for mercury has +2, oxygen -2. This is a free element, therefore it is 0. Its oxidation number of oxygen becomes 0 because it is a free element. So you can see from +2 to 0, from -2 to 0, therefore there is change in oxidation numbers. That's a redox reaction. For this, we have calcium +2, carbon +4, oxygen -2. You can even prove them by calculating. Then for calcium here +2, oxygen -2, carbon here +4, oxygen here -2. So we can see there is no change for calcium +2, +2, for carbon +4, for oxygen -2, -2. So there is no change. Therefore, it is not a redox. This is a redox, and this is not a redox reaction. If the other quick look could have worked for you very fast. So, but we wanted with a reason. So the reason is because here there is change in oxidation number, while here there is no change in oxidation number. Finally, as we wind up, practice questions. Identify which of the following reactions is redox. Number 1, A, B, C, D. I want to leave for you these. Please copy them. In the comment section, you can tell me for part A. Part A is redox. Part B is not. Part C is redox. Part D is not. Please let me know your responses as you try out these questions. Please do them and share your comments. You can even tell me which one is a reducing agent, which one is oxidizing agent, which one has been oxidized, which one has been reduced, and which one is a redox reaction, and which one is not a redox reaction with a reason. Otherwise, I want to thank you for being part of this session. For those who have not yet gotten a copy, we have 2 copies on the market, and people have taken these copies. Make sure you grab yours. If you haven't gotten one, we have for practical. This is summarizing all the practical to work, having all the accessible areas, the elements of construct for paper to worked example on each accessible area and practice questions there. So they are all here. So please make sure you order. The numbers are always there. They are here. You can email me on this email. We also have remedy. We have gotten remedy to chemistry. Remedy to chemistry. Do you want how to approach different scenario-based items? Please get remedy to chemistry. Your answer is here. You can get it for whether you're in senior 1, senior 2, senior 3, senior 4, because even a senior 2 can answer some questions. Senior 1 can do. When you look at your nail papers, they're not for only senior 4 work, but they range from senior 1. So this book is having items from senior 1 to senior 4, a competence-based curriculum. Grab your copy. I'll be waiting for your orders. Otherwise, have a blessed time. God bless.